Okay, students. So we'll go for second problem of divisible by k problem. Okay, the DFA. So the second question is draw a DFA to accept decimal strings divisible by 3. Okay. So from this question, we can easily identify k value will be equal to 3. Fine. They're mentioning decimal string. Okay. Then what should be the alphabet? Fine. Decimal string. Observe it carefully. Sigma will be equal to 0 to 9 exactly. Okay. Because of that, your D value will be equal to 0, 1, 2, 3, till 9 exactly. Okay. Then radix will be equal to 10. Okay. For decimal number, it will be 10 exactly. For binary, it will be 2 exactly. Okay. Like that. Whatever the base we are having, that will be called as a radix over here. Okay. So for decimal number, R will be equal to 10. Okay. And for this problem, D is equal to 0 to 9 and K will be equal to 3. Okay. So we'll go through this. The DFA can be obtained as shown below. So identify step number 1, identify the radix, input alphabets and the divisor K. Okay. In this case, R will be equal to 10 as usual. D will be equal to 0, 1, 2, 3, 4, 5, 6, 8, 9. Then later K will be equal to 3. Okay. So then we'll go for this step number 2, compute the possible reminders. Okay. After dividing any decimal number by 3, results in following reminders. Okay. Obvious. So if you are dividing any number with 3, then the remainder, what we can get is either 0 or 1 or 2 exactly. Okay. Which implies Q0, Q1, Q2. Okay. So the number of reminders, whatever we are getting, okay, those many number of states we used to have in our divisible by k problem. So here number of states are 0, 1, 2. Okay, so we are renaming it as what? Q0, Q1, Q2, yes, Q2. Okay, that's it. Okay, are the states of DFA. Fine. Now what we left with? We left with the transition exactly. Okay, so we'll go for the step number 3. Compute the transition. The transition can be computed using the following relation. Delta of Qi, A will be equal to Qj, where J is equal to R into I plus D mod K exactly. Okay, we'll start substituting with R is equal to 10 and K is equal to 3 exactly. Okay, so the possible I value will be 0, 1, 2 exactly. Okay, then what about D? See, in previous question, D was equal to 0, 1, right? So we were trying for like when we are having 0, then what will be the possible state we are generating? When we are having 1, what will be the possible state we are generating? Okay, only 2 conditions we had, we went through all the possible values of D exactly. But here, total number of D values are 10 exactly, 0 to 9, 10 we are having, right? So what we need to do, based on the reminder, okay, see like 0 to 9 also we are dividing it by 3. So possible reminders, whatever we are getting, according to that, we will start grouping them. Okay, we'll see this how this. Okay, there is a note. For the sake of convenience, let us group the digits from 0 to 9 based on the reminders we get after dividing by 3 exactly, as shown below. Okay, we'll see that, how we can group them. Okay, see here. We have a condition over here. Fine. See 0, 3, 6, 9. So this is one group we are making it as. Then 1, 4, 7, second group. And the third one is 2, 5, 8 exactly. Why we are making like this? See, if you are dividing these three number by 3, what is the remainder you are getting? 0 divided by 0. Sorry, 0 divided by 3. Okay, like 0 mod 3, 0 you are getting. 3 mod 3, 0 you are getting. 6 mod 3, 0 you are getting. 9 mod 3, 0 you are getting. So if you are dividing 0, 3, 6, 9 with 3, you are getting a 0 as a remainder. So we are making this 0, 3, 6, 9 as a value called as 0 over here. Okay. So whenever we are representing 0, that means that 0, 3, 6, 9 we are representing. Yeah, this is what the first group. Then the second group, okay, which is yielding 1 as a remainder. 1 mod 3, 1 we are getting. 4 mod 3, 1 we are getting. 7 mod 3, 1 we are getting. Because of this, wherever we are having 1, 4, 7, we are making it as a group, okay, and we are naming it as 1 exactly. Then later 2, 5, 8, we are making a group of 3, okay, which is having a remainder of 2 exactly. 2 mod 3, 2 only we are getting. 5 mod 3, 2 only we are getting. 8 mod 3, 2 only we are getting. Okay, so this is how, like D value, we are compressing it from 10 to 3 exactly. 0, 1, 2. Fine. So now, same thing we are writing over here. I value will be 0, 1, 2. Is it right? Okay, I value, the possible remainder, whatever we are getting from by dividing 3 is what? 0, 1, 2 exactly. So I value will be 0, 1, 2. Then what is the D value? D value is also equal to 0, 1, 2. Okay, why? Because of this conversion. Remember, because of this conversion, we are getting 0, 1, 2 exactly. 0 stand for 0, 3, 6, 9. Okay, 1 stand for 1, 4, 7. 2 stand for 2, 5, 8 exactly. Okay, fine. So now, here, we have written 2 over here. Actually, it is wrong. It should be 10 exactly. Okay, it should be 10 exactly. By mistake, we have written. Okay, radix. Okay, R. This is the place of R. It should be 10 exactly. 10 is constant. K is constant, right? Okay, so here it should be replaced with 10 and 3 exactly. Okay, equal to J. Then, so this is what the function which is going to generate the next state exactly. Fine, we'll see this, what we can get. So 10 into I value, right? What is the I value? 0 exactly. I value is 0 exactly. Plus, what is the D value? 0 exactly. 10 into 0 plus 0, 0 only you are getting. 0 mod 3 will be equal to 0 exactly. Later, 10 into 0 into, sorry, 10 into 0 plus 1. Okay, so mod 3. Okay, what is the remainder you are getting? 1 you are getting. 10 into 0, 0 plus 2. 2 only you are getting. 2 mod 3, what you are getting? 2 only you are getting. So we are writing it as what? Q0, Q1, Q2. Clear? Okay. See, 0 we are getting, so Q0 we are writing. 1 we are getting, so 1 we are writing. 2 we are getting, so 2 we are writing. Clear? Okay. This means, now I would like to explain. Okay. This means Q0 on receiving, see 0 stand for what exactly? 0 stand for what exactly? 0 stand for 0, 3, 6, 9 exactly. Q0 on receiving 0, 3, 6, 9, it will change its state from Q0 to Q0 itself. Means it is having a self loop. Clear? Now, Q0 on receiving 1, 4, 7. Okay, out of this any value, either 1, either 4, either 7. Okay, then it will change its state from Q0 to Q1 exactly. Like that it is. Same thing we are writing over here. See here Q0 0, 3, 6, 9. If Q0 is receiving any value out of this, it will make a self loop for Q0 exactly. Like that, we are representing all the possible transition, whatever we are getting it from D and I combination. Clear? Okay. I hope you don't have any doubt in case of this. Okay. So when we are observing the DF skeleton, then we can easily identify. Okay. So now this is what the DF skeleton. So Q will be equal to Q0, so like 0, Q1, Q2. Okay. Sigma will be 0, 1, 2, 3 till 9 exactly. Q0 is the start state. Again, F will be equal to Q0 itself because 0. Okay, see, 0. Okay, where we are having 0 is the final state exactly because like 0 modulo 3 should be accepted. Apart from that, everything should be rejected over here, right? Okay, so 0 modulo 3, whatever we are having, that should be accepted. Apart from that, everything should be rejected over here. Clear? Okay, so now, so Q0 we are making it as final state. Okay, sigma is like transition table. They are not mentioned in this example. If you want, you can draw it over here. Okay, transition table. Okay, so now observe it carefully. Like Q0 to Q1, Q1 to Q2, then Q1 to Q2 exactly, Q2 to Q0. So this is what the gesture of DFA we are having. Clear? Fine. Now we'll consider some examples over here. Okay, example of 16, example of 180, right? Example of 180. Then later example of 90, example of 19. Okay, so see, these are the few possible values. Okay, we'll go through this. 16, okay, divided by 3. What is the remainder we are getting? 16 divided by 3. What will be the remainder? 1 is the remainder, right? 180 divided by 3, remainder will be equal to 0 exactly. Okay, 90 divided by 3, remainder will be equal to what? 0 exactly. Then 19 divided by 3, remainder will be equal to what? 1 exactly. Because like 3, 6 are 18, so remainder will be 1 exactly. So out of this, 180 and 90 should be accepted. 16 and 19 should be rejected, right? Okay, 16 and 19 should be rejected over here. We'll see this. When we are getting 16, what is the first value? 1 exactly. See, Q0 on receiving 1, observe it carefully. Q0 on receiving 1, see here, 1, 4, 7 we are having. So this is a move made by a Q0 to Q1 when it is receiving either 1, 4 or 7 exactly. So on receiving 1, Q0 to Q1, what is the next value? 6 it is. Q1, okay, Q1 on receiving 6, here where it is self loop you are having. Means when you are receiving a 16, you will be remaining in Q1 itself, which is a non-final state, so it will be rejected. 180 you are having, right? So, okay. So Q01, when it is receiving 1, okay, so it will go for Q1, okay, fine. Then later, Q1 on receiving 8, okay, Q1 on receiving 8, okay, it will go make a move to Q0 exactly, fine. Later, 0 you are having, self loop you are having, you are at the final state when you are reaching the end of this thing, accepted. 180 should be accepted because 180 is yielding 0 modulo 3 exactly. Then 90, yes, again say, when we are having 9, self loop it is. When we are having 0, self loop it is. You are in Q0 itself. Okay. Then later 19, 1, 9. Okay. 1, 9 if it is there. When we are receiving 1, you'll be going for Q1. When you are receiving 9, you'll be going for Q1 itself. Okay. So this will be rejected. Now we'll see if you are using Q2. Okay. Let me design one value here. If I mention 1, then it will come for Q1. If I mention 7, it will come for Q2. Then if you are having again 7, okay, again 7, then what will be the result? Okay, can I try this? Okay, how the transition will be made by your DFA 177. If the question is 177, see, when you are receiving 1, it will come for Q1. When you are receiving 7, it will come for Q2. Again, you are receiving the 7, so you'll go for Q0 XL. Actually, it should be accepted. Okay. So 177 divided by 3. Okay. 59 za. Okay. 59 za. Okay. 59 za 177. 60 za like 180 exactly it is. That's why. Okay. So this is what the DFA, which is holding good for all the possible values of 0 modulo 3 exactly. Okay. If it is yielding 1 and 2 as a remainder, then you will be staying in either Q1 or Q2 exactly. Remember, okay, if you are yielding with remainder 0, then only it will be going for Q0 exactly. Clear? Okay, okay, students. So these are the two problems over divisible by K problem. So we'll with the next class, we'll go for the next variety of problem. Thank you.